Hey everybody, this is Mr. Longo, and we are going to take our modeling quadratics unit and do some application with it now. So Melissa is actually going to go drive a rocket, and if you were to read this question, she's going to be turning on her retro rocket to slow down because she changes her mind about going to Mars. So that's what we're going to do here. Keynote that it says that her distance is modeled in D kilometers as the distance from the surface of Mars, and T in minutes, since she started firing her rocket. So what we are given is some information that says that Melissa finds that at times 1, 2, and 3 minutes her distance from Mars are 425, 356, and 293 kilometers, and that's of course respectively, which means at 1 minute she is 425 kilometers from Mars, at 2 minutes 356 kilometers, and at 3 minutes she's 293 kilometers from Mars. So we're going to find a quadratic equation expressing D in terms of T. So again, this is one of our modeling questions where we know that y is equal to ax squared plus bx plus c. Now, if you forget how to do these modeling equations, you should probably go back and look at this video. So for this, we would get for our first one, we would have 1a plus 1b plus c, which is going to have a leading coefficient of 1, of course, and that's equal to 425. For the second one, we would have 4a plus 2b plus 1c, that's equal to 356. And the last one is 9a plus 3b plus 1c is equal to 293. Now that's our system that we need to use. So we also talked about in a previous video how to solve this using inverse matrices. So of course we would have 1, 1, 1, 4, 2, 1, and 9, 3, 1 times ABC, and that's equal to 425, 356, and 293. Now, we of course called it A and B in an earlier video. The names really don't matter. As long as you're taking the inverse of the first one and multiplying it by our matrix B, in this case, we will end up with a solution matrix of 3, -78, and 500. So we can write a quadratic model for this problem as D is equal to 3t squared minus 78t plus 500. Okay? And that is what we need to work with. So from here, we are going to go answer some more questions. Now, your graphing calculator would be very helpful for this. So if you would like it, go get it. So it says, find the D intercept. Well, that's like a Y intercept. So that's when t is 0. And if you were to just look at 0 in your graphing calculator on the table, it will give you 0, 500. So your D intercept is 500, but what does that mean in the real world? It means she is 500 kilometers when she turns on her rockets. And of course that means her rockets to get away from heading to Mars. And then we're going to answer some more questions. So according to the equation, where will she be at t equals 15? Well, if you just go look at the table of your graphing calculator after typing that into y1, you will find out that if we have d of 15 and substitute that into the equation, and you could do this by hand if you want to, you could just straight up type that or plug that into t, and either way you do it, you're going to end up with 5. So at 15 minutes, she's 5 kilometers from Mars. And then we type in or plug in by hand, however you want to do it, 16 minutes, we find that she is now 20 kilometers from Mars. So, does that tell us if she is approaching Mars or if she's pulling away from Mars? And since the distance from Mars is getting bigger, it means she's pulling away. Okay? So that's what's happening. Now the next part we're going to do is sketch a little graph of this quadratic. And it says a reasonable domain, so obviously we want to be starting from 0 and see what happens. So we know that this is 0, 500. We already figured that out. So let's see what happens. If you were to graph that in your graphing calculator, you're going to get a graph that looks like this. Now we have an issue. Our vertex, using, in this case, the minimum, finding the minimum with your calculator, is at 13, -7. So, the issue with that is -7 means 7 kilometers into Mars. So, does it tell us she crashes or just skims the surface or she pulls away? Unfortunately, she crashes. And she crashed with such a terrible velocity that, if there was no friction, of course, she'd be 7 kilometers into Mars. So, unfortunately, Melissa crashes. But anyway, that's it for this style of question. This is Longo, and I'm out. See you, bye.